right, so we've got, I've just put an example up here, and it's a simple one, so it's someone you've probably seen. So first we want to, so our question is, how do we find equation of the tangent to the curve at y equals x squared and at x equals 2? So we have two pieces of information, and we'll be given this in each question. So it will be the curve and then the x value that we're looking at. So the first step is always find the y coordinate value of your given x. And sometimes they'll give it to you. So they'll just say at the point 3,5 or 2,7. Okay, so the first step we want to do is find the y coordinate. So how would we do that?
Substitute x into the equation.
All right. And why do we find this? So the important thing to remember here is that the tangent and the curve share this coordinate. So both of them have this point, right? Which is 2, 4. So on a graph, this is what it looks like. So we're using this as an example, but remember this works for anything. So you could have a function that's y equals sine x ln 2x squared, anything, and you'll follow the same rules. It's just we're looking at a simple one, so it's easier to follow. So, okay, so that's our curve, which is y equals x squared, which is there. And then this is our tangent. And what's the equation of the tangent? So how do you know what the equation of the tangent is? It's always going to be mx plus c, because it's a straight line. And we know that that's the point, which is shared by this curve and by the tangent, which is 2, 4. That's why we can sub it in and get that point. So next, we want to differentiate the curve and sub in the given x value to find the gradient of the tangent. Okay, so just another recap. What happens when we differentiate a curve? What are we getting? When we differentiate it, what do we get? Or what does it tell us about it? Why did we just differentiate it?
Is it the equation of the tangent?
Not the tangent,
Okay.
but what is it made up of? What is a tangent made up of? What are the two things that a tangent has? So it has so if you look at the previous screen, it has the m value and it has the c value, right? So what's c? C is your like y-intercept, and m is your gradient. So whenever you have any curve, like this is y equals x squared, when you derive it, you're getting, well, it gives you 2x, but this is your gradient equation. So whenever you derive a curve, it tells you what the gradient will be at any x value. But in this question, we want the gradient at x equals 2. So that's why we sub in 2 into the derived equation. Is that clear? Because that's really important. Like this is a simple question, x squared, but even for the harder questions, it's the same thing. You derive it to get the gradient function, and then you sub in the x that you want the gradient at. Okay, so that's what we want. So we differentiated the curve to get the gradient function. Then we subbed in x equals 2 because we want the gradient at x equals 2. And so that's going to be 2 times 2. So our gradient is 4 when x is 2. Sorry, I actually forgot to write that. So the gradient of the tangent at x equals 2 is 4. Okay, so if you go back to our equation, then we know that this m is now 4. So when you derive this and you get 2x, that's going to give you the gradient of it. And then how can you get c from that on?
Do you just put in the points that you found before? So like the y and x coordinates?
Yeah, exactly. So now you know y, you know m, and you know x from before. So this is why we found the y coordinate in the first step as well. So sub in your x, y coordinate and the m value into the tangent equation and get your c value. So the tangent equation is going to be mx plus c. You know that x is 2, y is 4, and m is 4. So we found this by deriving the function, which gave us 2x. And then we subbed in x as 2, and we got 4. That's where that's coming from. So this m here becomes 4, and we just solve for it to get what c is, which is -4 in this instance. There is another way to solve it, which you'll see in your textbook. That works as well, which is you just go y minus y1 equals m times x minus x1, which is just another form of this equation here. So what you do here is your y1 is your y coordinate, your m is 4, and your x1 is your x coordinate. This will give you, this will work out to be the same equation. But I just find this easier because that's the equation of a line, and we remember that it's just more intuitive, so you can remember it that way. Okay, so if you go to the next one then, so our answer is going to be the tangent equation is 4x minus 4. Okay, really simple. Now, one thing that we did just going back is we derived it here using the power rule, right? Now, you're not always going to get this question. Sometimes you might get y equals cos x. You might get ln 4x squared. It can be anything. And so we need to know how to derive all sorts of questions to be able to find tangents and equations for all sorts of them.